Hi there and welcome to video 53. This one is on sequences and the nth term rule. I've already done a video on sequences and that was finding the next couple of terms in the sequence and other special sequences. This one is specifically for the nth term. Okay, sounds really mathsy. So keywords here: nth term, difference, zero term. So the nth term is just the anything term, any number term. All right. Some people think it means the ninth. It doesn't mean the ninth. It could mean the ninth, but it doesn't mean the ninth specifically. All right. It could be any number in that sequence. And it's a rule that we use to find any number in a sequence. The difference is the biggest take away the smallest, and you've found the difference. It's just how many numbers there are between two given numbers. It's found by taking away. And then the zero term is the term before the first one. All right. So what is the number that is before the first number in the given sequence? That's what we refer to as the zero term. Okay. Now the method is pretty simple. So we've got to find the difference between the term numbers. We've got to put that number that we found next to an n, which means that number is multiplied by n, and then we find the zero term. So the term that is before the first one, and we add that on to the thing that we just got by doing the first two bits. And then the second method I've got here is to find the first x terms. So find the first certain number of terms. It could be 5 terms, could be 8 terms, could be 3 terms. Find the first some amount of terms, please. That's what they're going to ask you. Now, just substitute the term number into the rule and then evaluate. That's a simple one, that one. Right? Now, I'm going to do the first question here. I'll do them relatively quickly because most people will pick this up really, really quickly as well. So, difference between 5 and 7 is 2. Difference between 7 and 9 is 2. So I'm going to put plus 2, and I'm going to put plus 2 and plus 2 again because the difference is the same. This is a linear difference, and it has to be if it's going to be an nth term linear rule. So I'm going to put that number next to an n, like I said. That means 2 times n. It's the 2 times table, but it's not the 2 times table, is it? But it's going up in 2, so we've got to find the difference between that and the 2 times table. So I'm going to find the zero term. So the first term there is 5 in my sequence. So the zero term would be the term before it. And I know I need to go plus 2 to get to it. So something plus 2 is 5. 5 take away 2 gives me the answer. It's plus 3. Okay, so it's a positive 3. That's what I'm going to plonk onto the end of that rule. And I've found the nth term rule for this given sequence. That is it. All right. Now it is useful for something, and you'll see what it's useful for in question 3. Now in B, I've got minus 3. And if I add something onto that, I'm going to get to the number 2. So I'm going to add 5 is what I'm going to add on. Minus 3 plus 5 gives me a positive 2. Then I'm going to add 5 again. So the difference is definitely 5 each time. Okay, and all that was really different here was we started in the negatives. So it's just 5n, just the 5 times table, but the difference between it. So we're going to find the zero term. So our first term is minus 3. Okay, the zero term is the term before it. I would have had to have added 5. So something plus 5 is minus 3. So I'm going to take away 5 from minus 3. And that's a little bit tricky to do, but you can always use your number line if you struggle. And there's a video in the number section about doing this. So take away 5 gives you minus 8. So that's the number I'm going to plonk on the end. I'm going to add it onto the end. Now, you could put plus minus 8, but you don't need to put plus minus 8. You just need to put minus 8. And again, that's to do with the rules of negative numbers. Again, watch that video if you're not sure what I'm talking about in the number section. Now, in C, we start at 4, and this time we are going down. We are taking away. So we're going to go minus 4, because you can see the difference is 4, but it's a negative 4. We're going down this time. So we're actually going to put minus 4 n at the beginning of the rule, and then once again we're going to find the zero term. So that would have been 4, the first term, and then we would have minus 4 there. So do the opposite thing, add 4 to it, that gives us 8. So the term before the zero term would be the number 8. So we're going to put plus 8 on to that. Hope that makes sense. They do kind of like to mix these up a little bit, and they kind of test your understanding on them. You might see these rules written the other way around. You might see it as, if you've got this one here, for example, you might see it as 8 minus 4n. Let's put that as well. 8 minus 4n. That is the same rule as this. It's just that minus 4n term is written after the positive 8. And they do tend to like to do that and test your understanding there. So just be wary of those. If you see something like that, you think, oh, okay, they've just switched it round. You can always put that back over before there if you like it in that way round. Now let's look at number 2. So number 2, I've got 2 questions in number 2. Got to find the nth term rule for the following sequence. This one is fractions, okay, and it looks really scary, but I wouldn't worry about it because you've got to ignore the bottom of the fractions, first of all, and just look at the difference here on the top. So that's 2, 2, 2. So the difference is 2n, okay, and then the 0 term would have been plus 0. So it's literally just 2n because it is the 2 times table. Okay, and then what we're going to do is ignore the top now of the fraction, put a little line there for our fraction of our answer, and then we're going to look at the difference between the bottom numbers. So that's going to be plus 5. I'll write this one, plus 5, plus 5, plus 5, and that's going to then be 5n, and then to find what the 0 term would have been, we go back one, and it would have been minus 1 here, wouldn't it, on our fraction, so we'd have a minus 1. There we go, and it looks really complicated. It's fractions, it's literally just doing the same thing as what we did twice. Do it for the top of the fraction, you do the rule for the bottom of the fraction. And there's our nth term rule for that, which is pretty pleasant, really. Looks really cool, looks mathy, looks like you know what you're doing. Now, in B, you've got to find the first 5 terms of a sequence with the rule 3n minus 12, and then you've got to decide if the number 450 is a term in that sequence. Now, these tend to be on calculator papers, so I'm going to bring a calculator in for this. This one, because I don't want to spend forever doing it. You can do it without a calculator, but here we go. There's our calculator. And let's see if we can move over here a little bit. Oops. There we go. Come on. So 3 multiplied by something minus 12. Well, the first term number is 1. So 3 multiplied by 1 and then plus, nope, wouldn't put plus in. We'd put minus because that's 11. Definitely don't put 11. There we go. We're going to get it right eventually. So 3 multiplied by 1 minus 12 is going to be the first term number. So the first term number is minus 9. I'll write that down. Now, this is why I'm getting a calculator in as well. What we can do on the calculator is we can just go back in and we can just change that 1 to a 2 because the second term number, funnily enough, is 2. And then we're going to get minus 6. And then we're going to go back in again. Just keep pressing this back button. Change that 2 that we want it to know to the 3. And we're going to go minus 3. You can see what's happening here. It's going up in 3 each time. It's not a coincidence because that number there in front of the n is a 3. All right, so you could just go, well, I know it's going to be 0. And I know it's going to be then 3. But just be on the safe side. All right, so the fourth term number there is equal to 0. Okay, and then the last term number is 5, so 3, like I said. All right, so there you go. There's the first 5 terms for that sequence. Now, is 450 a term in that sequence? So there's the first bit of the question done. All right, is 450 in that sequence? Well, if we took away, if we added 12 to 450 and then divided by 3, let's just see what that gives us. So we've got 450, and I don't like this calculator sometimes, 450 plus the 12, and that equals 462. And then we divide that by 3. If it gives us a whole number, we're winning. There we go. It's the 154th term. That's what it is. So it's given us a whole number. So yes. And yes, it's the 154th term is what I would write there. Okay. I hope that makes a bit of sense. All I did was make it an equation. I made this equal to this and then worked it out and saw if it gave me a whole number answer. All right, so I'm just going to get rid of that for a second, and then I will just pause the video for a second because my children are home. There we go. I'm back again, and you didn't really notice a difference. So I'm going to move myself over there to look at question number 3. Now this is where the finding the nth term rule comes in really, really handy, and understanding how to do what we did in part B of question 2. So calculate the difference between the 30th and the 50th terms in the sequence that starts with these numbers. So we're going to go and see what the difference is again. So we've got plus 7, plus 7, plus 7, plus 7. Every time we're doing it, we're adding 7. It's a linear sequence. Therefore, the rule is 7n, and then find out what the 0 term would have been. It would have been a minus 3. So our rule is 7n minus 3. Now, that rule can be used to find the 30th term and the 50th term accordingly, and then we will be able to work out the difference between those numbers. So let's find out what that is. So 7 multiplied by 30 minus 3 equals, and 7 multiplied by 50 minus 3 equals. Again, I'm just going to bring the calculator in to do these things, do it a little bit quicker. 7 multiplied by 30, just move it over a little bit, minus 3 equals 207. Okay, 7 multiplied by 50, just go back in, change that 30 to a 50. Ice cream van outside, I don't know if you can hear that, 347. Okay. And then we're going to find a difference between those two numbers. So 347 minus 207 is what we do, and 140 is the difference. So I'll just write down what we did there. 347 minus the 207 equals the answer of 140. All right, now I hope all of that makes sense. If not all of it makes sense, then I hope that at least question number 1 makes sense, because I think they're an easy couple of marks to get on exam papers. The rest of it is more complicated, hence the reason why I've gone through it in detail for you. Please like, subscribe, and tell your mates about this. All right, no matter what school they go to, they can learn from this, I'm sure. I hope they can anyway, otherwise why am I a teacher? So there you go. Click the link in the description, practice the resources, and have a lovely rest of whatever day it is you're watching this video on. Bye bye, see you next time.